Hello and welcome back to ShortGATE. In today's video, we are going to cover a powerful CPU scheduling algorithm that is shortest job first. This is a very important topic for both gate theory and practical applications in operating systems. We will break down how SJF works, its advantages and disadvantages, and see how it compares to other algorithms like FCFS. Let's get started. Let's see what is shortest job first. SJF is a scheduling algorithm that selects the process with the smallest execution time, means burst time, and run it first. It's designed to minimize the average waiting time for all processes by prioritizing shortest tasks. However, it can either preemptive or non-preemptive depending on how the CPU selects the next task. Here, how SJF works in a simple step-by-step breakdown. All processes enter the ready queue. The CPU picks the process with the shortest burst time. The selected process runs until completion for non-preemptive and until a shorter process arrives for preemptive. Once a process finishes, the CPU checks the queue again to select the next shortest process. Let's quickly differentiate between the two types of SJF scheduling, means non-preemptive SJF and preemptive SJF. What is non-preemptive SJF? Once the CPU starts execution a process, it completes it without interruption, even if a shorter process arrives. For preemptive SJF, which is also known as shortest remaining time first or SRTF, if a new process comes with a short burst time, the current process is paused and the new one is executed first. Let's consider an example with four processes. P1 arrival time is 0 and burst time is 7. P2 arrival time is 2 and burst time is 4. P3 arrival time is 4 and burst time is 1. And P4 arrival time is 5 and burst time is 4. For non-preemptive SJF, the CPU will pick P1 first, since it has arrival time 0. After P1 completes, it will select P3, since it has the shorter burst time. After P3 completes, it will select P2, because its arrival time is lesser than P4, and finally P4. For preemptive SJF, if a new process arrives with a burst time smaller than the currently running process, the CPU will pause the current process and execute the shorter one. Here, the CPU will pick P1 first, since it has arrival time 0. Then P2 comes at time 2. Now the remaining burst time of P1 is 5, but the burst time of P2 is 4, so P2 will get executed. In this way, P3 will come and again P2, then P4 and P1. Now, in this way, scheduling is done for preemptive SJF. SJF has some clear advantages. Minimizing the average waiting time. It's designed to reduce the overall waiting time of a process. Efficient for small and predictable tasks. When burst time are known, SJF can optimize CPU utilization. But SJF is not perfect, and here are its downsides. Difficult to predict burst times. In real system, knowing the burst time beforehand is tricky. Starvation. Longer process can be indefinitely delayed if short tasks keep arriving, leading to a form of process starvation. Let's see the time complexity. The time complexity of SJF depends on how the processes are sorted by their burst time. Sorting the process takes order of n log n time, where n is the number of processes. Preemptive SJF adds more complexity because the CPU needs to constantly compare the remaining burst times. For best cases, the time complexity is order of n log n, when burst time are easy to predict and there's no interruption. And for worst cases, it's order of n square. In preemptive SJF, if many short process keeps arriving and interrupting longer ones, and the average cases is order of n log n, as it typically involves sorting the processes based on the burst time. Thanks for joining me to learn about the shortest job first algorithm. If you enjoyed this video, don't forget to like the video if it helped you understand SJF better. Subscribe to ShortGATE for more GATE OS content. Drop any questions or topics in the comment below. Thanks for watching. In the next video, we will dive into round robin scheduling, a preemptive algorithm that's widely used in time sharing system. Stay tuned, keep practicing because together we are going to crack the gate.